Hi, welcome. In this video, we will solve problem reverse bits asked by companies like Amazon, Microsoft, Google, Apple, Uber, and Goldman Sachs. Now let's solve one more problem on bit manipulation. So we have reverse bits. So basically, what is the problem statement? Basically, we need to reverse bits of a given 32 bits unsigned integer. What is unsigned? That means not assigned. That is not -3, -4. It should be right unsigned, right? Value will be absolute value, not with any sign. Okay, plus or minus. But in Java, there is no unsigned integer type. So here in the cases, both the input and the output will be signed integers. So if you are doing it in Java, right, you can simply represent your answers in the same type, right? It won't affect. The only thing that you need to remember that here in Java, the signed integer types basically use two's complement notation, right? So if there is a negative integer represents the signed integer, like suppose -3, that is given in the Leetcode problem itself, there is a note, then the output also represents the signed integer. Okay, but that is specifically for Java. Okay, now let's see. Now let's see how basically what is this problem statement. So here you can see this is a 32-bit unsigned integer, right? There is no sign in the input, right? So and these all are right. If I simply count all these, this will be a 32-bit. Okay. So if I'm taking the few of the last bits so that we can understand the examples. Okay. So basically here, if you take the last 5 digits, right? So we have 11100, right? So here in the first, I will say, or yeah, first position, this is 0. Then in second position, this is 0, third 1, fourth 1, and fifth 1. So when you will start from here, right, on the 32 position, right, you will find 0. Then on the 31 position, you will find 0. And then like 30, 31. So you can see your first 5 are the last 5, right? 11100, it's now 00111, right? If you are taking this more digit, right, 100 here, so you will get 001, right? Basically a reverse. So basically these two outputs are reverse of each other, right? Similarly here you can take, we have 11101, right? So how it will start, basically 11101, and it the reverse will become 10111, right? So you can see 10111 we have in the last 5, and basically I need to reverse all 32 bits. Here I am just showing you 4 or 5 bits basically to understand you, but basically we need to reverse all the 32 bits. So let's see, let's understand the problem statement in a much more better sense. So as we have, suppose input, I am not taking the 32-bit, I am again taking the 5 bits. Suppose I have an input like this 1101, right? And what is my goal? I want to basically reverse it, so the final output will be 1011. Okay. So how we will solve this? We will try to use the intuitive approaches, right? There are other approaches as well, right? But that is not intuitive. That's quite of memorize, right? You need to memorize some things to basically reverse it. We will be a bit more intuitive. And how? What we will use? We will use again the same bitwise operators. Whatever we have studied so far, bitwise operators, we will use only that. So we will use and, or, right, or left shift and right shift. So let's see here. So we have 1101, right? And I want to make 1011, right? So what I will do, I will simply check, right, each digit, each bit one by one. So basically the most least significant bit will be this one, the least significant bit. What I will do, I will first check this one, right? I will first check this one and try to add into my answer. So let's see. Basically, I will take some variable. Let's suppose I have take reversed with 0. Right? I am starting with reversed 0. And what I'm checking, I am checking this bit, right? So now suppose If there is 1, I want to extract 1. If there is 0, I want to extract 0. If there is 1, I want to extract 1. If there is 1, I want to extract 1. So which operator should I use so that I can get the same value as it is? Same value as it is, right? If you can remember, we have one operator, let's suppose n, and if I'm doing n and 1, right, it will give me basically the value same itself. Suppose if any digit, right, we have 1, right, so 1 and 1 will give me 1, and if there is 0, 0 and 1 will give me 0, right? So here I am getting exact value as it is, right? So what I will do, I will do this, basically I will do n and 1, so I will get this one, right? And now what I need to do, I need to basically add this one to here, right? So that we can basically start and understand this, like that you have not something, you have know something, you will simply add one here, right? Similarly, I will get this 0, suppose here, and what I will do, I will add here. Similarly, I will get this 1 here by end, and I will add here, right? Similarly, I will get this one here, and I will add here, right? And this is how my whole bits will get reversed. This will be my approach. So let's see how we will do it, right? So again, I'm starting reversed with 0, right? And I'm taking an end. By this, the result will be 1. Now what I will do, I am getting this 1, okay? Let's suppose this value is, suppose x or bit. This is my 1 bit. So this is my 1 bit, right? And now what I will do, I want to add this value, right? So see, how to add a value, basically, if I suppose if there is a number 0 and I want to add 1 to it so that the result will 1. Suppose if there is 0, or I want to add 0, so I want this result to be 0. And suppose if there is 1, and if I am adding 1, it should be 1, right? Suppose if the result is 1, right, and I am adding 0, so what I want this should be 1. So can you tell me, like, where I will get these answers? Value is 0, I am adding 1, I will get 1. Value is 0, I am adding 0, I will get 0. Value is 1, I am adding 1, I am getting 1. Value is 1, I am adding 0, I am getting 1. Yes, correct. This is bitwise OR. Bitwise OR. If I use bitwise OR, right, between the value and whatever the thing that I am adding, it will give me the added results, right? Suppose the last bit that I am getting from here, that is 1, right? Suppose the last bit that I am getting from here, that is 1 here. So let me, instead of this example, let me say bit, and I want to add in my reverse, right? So what I will do, I will see do bit or reverse. So basically what it will do, it will add my value, right? So as of now it is 0, and if I do 0 or 1, it will add it, so it will put 1 in the reverse. Similarly, suppose if I am getting in my bit, that is like here 0, right, and in my reversed it is also 0, so basically it will add 0. Suppose in my bit I am getting 1, right, and reversed, what I will do, always I will try to make reverse 0, and it will add 1 basically. And here suppose in bit I am getting 1, if there is 0, it will add 1, right? So that's why we will use OR operator. So let's see how this will work. So we have 0001, basically this one value. So in my bit I am having 1. So I will take a left shift of reverse, left shift, because I want to create an space, right? I want to create an space so that I can add this bit. So what I will do, I will do a left shift of my reverse, and if I am doing a left shift, right, it will be like this. And what I will do, I will take an OR, right? I will take, this is an OR operator, remember, OR operator, right? Bitwise OR. So if I am doing OR, what it will be, answer will be 1 0. So my reversed will change to 1 0. Sorry, 0 1, like this, right? Now after this, again what I will do, again I will do the same again, but what I will do, I will do a right shift because this least significant value work is done. So what I will do, I will do the right shift and I will make 1101 to this one, right? I will do the right shift and now it will become 110. Again, what I will do, I will simply check the least significant digit. So I will get 000, right? Basically, this is also 0. So what is my bit here? This will be 0. Again, what I will do, right? I am getting 0, 1. Before adding this bit, I will simply do again right left shift. So reverse will be 0, 1, 0. So that this space will be treated with my bit. So now 0, 1, 0. I will again treat with OR and 0, 0 will result in 0, 1, 0. Right? Again, what I will do, I will check my answer. What is the answer is left? 1, 1, 0. Right? I will again do a right shift. If I am doing the right shift, what I will get? I will get 1, 1. Right? I will simply do AND with 1. Right? I will get 1, 0. So basically my bit will have 0, 1. Right? Again, what I will do, I will first take the reverse, right? The right shift equals to 1. So it will become 0, 0, 1, 0, 0, right? 1, 0 more will be added. And once this is done, right, what I will do, I will take an OR with the bit that is 1 and my result will be 0. Basically, or I am taking so 1, 0, 1, 0, 0, 0, 1, 0, 1. Right. Now after this, again what I will do, I will do the right shift. So if I am doing the right shift, I will have only 1, right? Because basically 1, 1 again I will treat with the right shift. So it will be 1 only. Now what I will do, I will again take 1 and AND with 1. What I will get? I will get 1 as an answer. And again what I will do, before starting, I will simply reverse it. Basically right shift it, right? Right shift it. So I will do 0, 1, 0, 0, right? Again after this, what I will do, I will simply take an OR with my 1, OR with 1, and it will be 1. It should be 101, yeah. 0, 1, 0, 1, right? This was the result, 0, 1, 0, 1. And if I am adding 1, 0, it will be 0 now here, right? So now if I am taking an OR, it will be 1, 1, 0, 1, 0. Right? And my final result will be 0, 1, 0, 1, 1. Right? Now what we will do, basically, this is exactly my answer, 1, 0, 1, 1. I am getting 0 and this 0 has no significance because it is coming at the front, right? So basically I can simply, like, if you read this one or if you read this one, both are same, right? So here your answer will be same. But remember, in JavaScript, what we will do, basically we need to do a right shift with 0, because the right shift with 0 basically makes it unassigned. Okay, so if we have any number x and if I am doing a right shift like this, because the right shift sign in JavaScript is like this, if I am doing this, it will make it unassigned. Clear? Right? I hope this is clear to you. Right? Let's to understand a bit more, let's try out one more example so that we can understand it a bit more clearly. So we have suppose 1, 0, 0 and 1, 1, or let's take some other n and we have 0, 1, 1, right? Like this, 3 digit. So I will make it 1, 1, 0, right? My final outcome will be 1, 1, 0. So now remember the steps what I am doing basically, right? What I am doing, what are my steps? The first step is what I will do, I will simply take an AND, right? So I will apply bitwise AND, right? After this, what I will do, whatever my answer, this will give me bit. I will take, before that, what I will do, I will do a left shift with my reverse. So left shift of reverse, so that will add up space. It will add a space. Now after this left shift, what I will do, I will take OR, so bitwise OR, like this one, right? So I will take bit or reverse, right? And the fourth step will be, then I will simply do whatever my answer, that is n, I will right shift n, right shift the input basically. These are the 4 steps that we are going to do. And let's understand one by one. I am again starting my reversed with 0, right? And we have n with 0, 1, 1, right? So if I am having n with 0, 1, 1 and reversed 0. So what I will do again, bitwise AND. So first of all, I will do bitwise AND with 1, right? So 0, 1, 1 and 1 will result in 0, 0, 1. Basically, this will be 0. So my bit value is 1 here, right? What I will do after this, right? Left shift reversed, I will reverse and add a space. So this reversed, I will simply do a left shift. So reversed left shift 1. So basically this will add a space here, right? So this 0 will become double 0. Now what I will do, I will do with bit. So I will simply do bitwise OR. So I will say reversed or bit. So 0, 0 and 1, or this will be OR basically, OR. And 0, 1 will become 0. Sorry, 0, 1 will become 1 and 0, 0 will become 0. So now my reverse is changed to 0, 1, right? After this, your reverse is changed. Again, you do right shift the input. So I will do right shift the input. What is my input? This is my input. So now it will become 0, 1. So now it is 0, 1. Again, let's apply the same step, bitwise AND. So bitwise AND, this will give me 1, 0, right? Now what I will do, again I will do reversed in bit. First of all, add the left shift reversed, add a space. So I will say left shift, add a space. So 0, 1, it will become 0, 1, 0. After this, I need to do bitwise bit and reversed. So I will simply do, I will add a OR. So it will become 0, 1 and 1, right? So now my reverse will change to 0, 1, 1. Okay. And after this, what I will do, I have done right shift the input. So now I will again right shift the input. Now the input will be 0. And again I will take with 1. So 0 and 1 will give me 1. My bit 0 and 1 will give me 0, right? So it will be, this will be my bit. What is the next step? Left shift reverse. So now again I will do left shift reverse. What is my reverse? 0, 1, 1. So it will become 0, 1, 0, 1, 1, 0. Now bitwise OR reverse. So what I will do, I will take an OR with this 0. And what will be my answer? It will be 0, 1, 1, 0, right? So now here after this, what I will do right shift the input. So now if I'm doing right shift the input is done, right? Input is 0 and this will be my final output, that will be 0, 1, 1, 0. Basically the front 0, if I removed, it will be 1, 1, 0. And how basically I will remove it? I will simply do reverse right shift 0. Basically it will change to unassigned, right? It will change to unassigned. See, if I am removing it or not removing it, still it's the same, right? So 0, 1, 1 will be read as 1, 1 because this is 0, right? Basically 0, 20 rupees. It will be called it as 20 rupees. 0, 0, 40 rupees. We call it as 40 rupees, right? So similarly here, 0, 1, 1 will be treated as 1, 1 only. So now my final answer is 0110. That is, you can read it as 110. That is a reversed of 011. Clear? So I hope this is clear. Basically, we need to apply these operations, and like you can see, I am taking each bit one by one. So if there are 32 bits, I will simply do this 32 times, right? So basically, I need to run a loop that will run for 32 times only, and I will do these things again and again, and then we will get the final output. Okay. So see, now in the next video, I will give you a code implementation of this. So we will understand basically how this code is work. Okay. So yeah, see you in the next video.